Right, this is the tutorial I have of, we're going to try to do a piston and liner and crankshaft combination of a motor. In here, where the main thing is I'm going to show you how to make individual parts in a single design and then using those to have some sort of a relationship so they can be moving. The moving part will probably in the next tutorial. We're just going to be making multiple parts inside a single design. Um, and we'll get to something like this. Just let me stop this because, okay. And so this is the model that this was based off. And obviously here we have our individual components, and we're going to get to some setup where we can get these individual components of the piston and liner combination. And then we can even go into more detail, like we can do more detailed parts like C-clips inside the piston and such. And some things don't actually matter because then we don't need them to move relative in our design, but this could be relevant if we do like stress analysis later and we're going to have, if this internal clip's not here, we're going to have like a groove inside there. So that could matter for that. So we'll start by making a new design. We'll make a part design. The way I did this is I started by making the piston first. Now, all my dimensions, they don't actually matter because I'm just spitballing them and doing them quickly. Do things that make sense visually. Obviously, if you have a real design, you can base it off that single dimension. To do our piston, we're going to be creating on this flat surface. We'll start by making a circle. Let's say we just make it 50 mil diameter. Done. And then I'm going to start by making the skirt and the outside of the piston first. So I'll make a sketch. What I want to do is I want to have another circle on the, hold on, I'm not doing a sketch. Let me edit this first sketch I did. So when you would have previously had Fusion, you would have had this circle, and then you would have got this circle, and you would have extruded this circle into, a cylinder, and we could work with that. But let's try to be a bit more accurate with our drawing here, because when we combine this later, one of the ideas that engineers use CAD for is they can change their design halfway through. So let's edit this sketch. We know the inside of the pistons are typically hollow to save weight. Because you don't want a large weight moving up and down at like 3,000 times a minute. That's going to produce unnecessary load. So we know that the cylinder is going to be hollow. And so what I want to do is just another circle here, and I want to start using the sketch dimension tool and use that so I can manually put in the exact distances I want. So I may have sped through that. Let me do that again. So we're going to go create. So once I have my two circles, I'll go create sketch dimension. I'm going to click the inside diameter and the outside diameter, and then see how my arrow is showing the distance between those two circles is 7. And so I can change that now. So I can say I want the outside skirt of my piston to be, let's say, 2.5 millimeters. That's the size. But also, it's shrunk the outside of my cylinder. So what I'm going to do here is I'm going to create sketch dimension. I'm going to click the outside of the cylinder. And over here, I'm going to make this again 50. Cool. Now, if I wanted to then also adjust the inside diameter using sketch dimensions, create sketch dimensions, it's not going to let me do it easily because if I click it, it's going to say, you've over-constrained this dimension. You've already said how much you want the outside diameter and how thin you want the skirt. Then you can't also choose the inside one. So that's called it can be a driven dimension. So you can get it just to show the answer, but we can't adjust it. So we don't need that one. Then in my particular sketch where we're going to have the wrist pin attached inside the cylinder, we want a bit more meat over here in our piston. So we're going to get a line. Let's say we just want, I want to bring my mouse anywhere over here where it has that X, which means it's attaching to that line. I'll just click anywhere and I'll just go straight down to the other side. And this line, I can do the same thing. I can do a sketch dimension. I can press this line and I can say how far away I want that from the center. And I can pick a number. Let's say I want this to be 15. 15. And then that line's going to come out at 15. And then I can we can do another line like this. We can just join this one manually because if that way it will follow the other side. And then I will, well, I'm not going to mirror it because I'm going to cut this cylinder in half just like in our previous example. But I have my shapes here, and the last thing I'm going to do before I'm ready to extrude this to make this into a 3D object is I'm going to fillet this, I want to fillet this rounded part over here, but it's not going to let me fillet here because I have a circle and a cut line, and it doesn't like that. So how I found we do this is we do actually cut this. Am I off? Is my view off? Okay. We will actually cut this cylinder in half by doing a line just right through the middle, and we're going to use the trim tool, and we're going to get rid of this half of the piston that we don't need. So this is the part of the piston, the drawing we don't need. And now I can go to my filleting tool and I can press this portion and this portion. That's going to just make it look like a more realistic piston. Finish sketch. This is going to be the skirt of our piston. I can press extrude and select this profile, and we can just make it, why are we upside down? And we can just make it as large as we want. So this is going to be everything except we'll do the crown, which is the very top part, piston after. So let's just say we want this to be 30 millimeters, is just the dimension I have here. And I'll press OK. And then I can make the top of the piston as well. I'm going to sketch based on that top graphic. Make a whole circle, press finish. And I'm going to extrude. And for this part, let's just say I do the whole thing. And let's say I want it to be 5. And now we can add some features as well to this particular piston. Let's say we want to add some of the ring lands for where we're going to put in like the O-rings and the oil stuff, the oil grooves. How I would do that is I would go sketch. I would sketch on a side profile, and I want to use this line as a guide for where I'm going to like gouge out some lines in my piston. Before we do that, we're going to project and include this shape into our drawing. Is it project and include? Project. So I have these lines here, and now I'm just going to freestyle something that I think looks good. I don't know. Okay, so I have these lines here. I want to make sure I have these little, I want to make sure I have these parts. These are the parts I want to cut out. Yeah, okay. We'll finish that sketch. We will then, I need this diagonal line, so I need to actually edit that sketch a bit more. So I'm going to use the revolve tool, and I want to select these parts. I want to select this and this, this, and I don't have the big. I guess we can do this one. Actually, we will ignore the bottom one. I will just do those ones, and the axis I want is the axis of the cylinder itself, and then I'll press OK, and it's going to cut that part of the cylinder, and it's going to give us what the top of the cylinder will look like with the ring lands and the crown. Then we will make the hole for the wrist pin. We'll sketch on this wall over here. We will pick a place that makes sense, and we'll just do a hole. 10 millimeters is fine. It's okay. Extrude this out. And then we have that hole over here. So next step, so this is our first body we've made, and what we're going to do is we're going to start labeling these bodies because it's going to get confusing very quickly as we add more and more bodies here. So we're going to name this as the piston. Piston part. The next part of the piston we're going to make is the wrist pin, which is the part that connects inside here. So we're going to create sketch. We'll create it. We'll use our piston itself to make this part, because if we press that face as the basis of our sketch, we can use its geometry to make components. So I have that circle there, and I finished that sketch. So we have this profile over here. We can extrude. And this particular shape, if I bring it out, I just want to bring it to the halfway point because we will be copying everything later. But I want it to extrude in both directions here because otherwise it's not going to come out into the piston and it's not going to look like, it's not going to make sense. So I'm going to do a two-sided extrusion. So let's say I want it to come into the pin about by 6 millimeters. And we can do later when we do our stress tests, how much we overlap that is going to be relevant because that's how much contact those particular surfaces have. By default, if I press OK here, they're going to be joint and it's going to be a single component, which is okay if you're just doing a drawing, but we are going to be animating all these later. So I need these all to be individual bodies or they're all going to be moving together. So instead of joining, we're going to say new body over here and then we'll press OK. And then we'll rename this wrist pin. And then we see we have that component there. We can use this new pin's location over here to do that little groove that I have in my other drawing for us to put in the circlip. In Create Sketch, we can press this face over here. We know this is going to be slightly larger. So let's say I want, that's the inner dimension, and I want the outer dimension. We can use our same sketch dimension tool. We can say we want the 0.5 millimeters. We want it how much for it to cut in. We'll press OK. And then we'll go to extrude, and we want to extrude this 1 millimeter. And if we press OK, is it going to join them together? No. Okay. So now if we hide this wrist pin, we see how we have this little groove here, which we can use to model, like in my other model over here. I have this little internal C-clip that we can model in there. So then we can know one of the reasons why we can use CAD over here is we can measure this. We can press the inspect tool. We can see what this outer diameter is, and we can measure it. And its radius, its diameter is 11 millimeters. So I already know that I need to get a circlip that is that particular size. We know what size parts that we already needing to order for this particular piston. Then we will go with the connecting rod, which is also called the Conrod, I believe for short. For this one, again, create a new sketch. For this one, I will just pick the sketching plane. I don't need the piston for this one, so I'm going to hide the piston, but I do need this wrist pin. So I'm going to press in create, I'm going to make sure I use it by pressing the project tool, and I'll press that surface and I'll press OK. And so now, even if I hide the wrist pin, I see that purple circle. So it's saying, hey, use this geometry. I want to use this geometry. I'm then going to make another circle on the outside. And again, I'll use my sketch dimension tool over here to say how thick I want this. Let's say I want this one to be 5 millimeters thick, is how much meat I want around that particular part of the piston. And then let's pick a point. I can pick the length of my Conrod by going down. Let's say I want 100 millimeters is the length of my Conrod. And I can confirm that by going to my sketch dimension tool and saying over here 100. So 100 is that length I want from the hole where my wrist pin and the hole of where my crankshaft is going to be connecting in the Conrod. Let's make this one slightly larger to make it look cooler, I guess. 30. That's the diameter of the inside bearings. And I can continue by making the outside by the same process. So I do the second circle, I do the sketch dimension, click here, click there, and let's say I want this one to be 20 mils. Actually, that's too big. Too doesn't look right. Let's go 10 mils. Okay. So that is 10 millimeter for that part. And if we look at some diagrams of if you look at some diagrams for connecting rods, they have it wider at the base to accommodate some sort of a bolt connecting the top and bottom of this together. So we can do that. We can send a line out here. We can say we want to go to 30, and then we can say we want that to be 10 mils high, and then connect it like that. So when we make this in 3D, it's going to look better. Then we will want to connect these two together. You can do a process of just we can press constraints, I believe, constraints, and we want tangent. We can press tangent of this circle and tangent of this circle, and it should just generate us a line. We'll generate a line here and here, and as we bring our mouse over, when we get the circle, when we get that symbol, that's the tangent symbol, and I believe we can edit this top one over here. We can drag it. Can we make this one? How do I make this one a tangent as well? If we highlight both the curves, there we go. I can make it a tangent on the top and a tangent on the bottom. So it's not a very good looking part, but that gives you options if you need to get two particular lines that are tangented together. But that's like the simplest form. We might use that later for our crankshaft, because that's a good looking shape for that. But in most images of pistons that we see, they don't have a line going that way. It's usually like vertical to make it even thinner. So we can do that. Let me just delete this part. Delete. We will get a line here going straight down. And then we can use, what are we going to use? We will modify, we'll cut this over here so we can use our filleting tool to make this edge rounder. There you go. We don't have to round off this part because that part is fine. And then all we've got to do is cut off the parts we don't want. We don't want this part or this part. We need to finish, we have to bring a line up here through the top. And we might have to do this actual circle over here. Okay. So that's the shape that we're going to make the shape that we're going to make into 3D. We'll extrude this. And we'll just open up the other parts so we can visually see to have it make sense. Of it that thick, sure. That looks like it's fine. 10 millimeters, wonderful. Again, we don't want to join. There's going to be a new body. And this new body we will call connecting rod. Now, my other drawing, I have it making it look a bit fancy. We want to thin it out. We know these typically have the inside as being hollow to save weight. So we'll hide these parts. Feel free to constantly hide and unhide parts of your model so you can get access to the detail. Sketch this part over here. There are a few ways I tried before. If you press offset, it sometimes works. If you press offset, you can like get the general shape of the parts you want to cut out. So you could do like that. But I want to do it. The only issue with this is it's going to want to cut out this part of the bottom, which isn't really ideal for us, but we can use this offset tool. We can say minus 2.5, which is going to give us this particular shape. And it's going to give us this line. We don't have to use this whole line. So let's say we don't want to cut into this bottom part for reasons, right? So what we'll do is we can, we're still editing the sketch. We're still editing the sketch. We can still go here and let's say we don't want anything. We don't want anything under that. So then we can cut off everything we don't need. Oh, sorry, not that tool, this tool. We will keep that. And now we should be able to fillet these, right? Is it not letting us fillet? Why isn't it letting me fillet this? Is it because it's not touching? Interesting. We just select both if we select both the curves, we can fillet it. So let me show that again. When we select a curve, we just hold the shift button and then we press the other curve and then we press the fillet and then we get that nice little fillet there. We can do the same thing up here, I assume. We will press this shape and this shape. We'll have that lovely 1 millimeter fillet there. One thing we didn't consider is it's going to cut out this part in the middle. We don't particularly want that, so we'll just use our drawing tool to force it to make some parts that make sense for that. Okay, so now if I think this is done, I should be able to select both of those profiles and we'll extrude this. Now in my presentation, see how this is, this is right, this is on the correct side that I want it to be on. And so my idea is we'll end up doubling this later to make it double as thick. But for now, this is just the shape I want. We will bring this in, press OK, and there we have like the inside of our piston now, which could be relevant again when we do our stress test. We can see if that's going to work for the shape of our piston. So now the last part we're going to do is the Conrod, and here is here's how I did it. Is okay, sketch this part over here. So here's our first part that actually matters, because as we're going to rotate our piston, I'll actually show you here's a good point to show you this particular final drawing. As we, can I modify? When we have the piston at the bottom, like this, we see here the length between, this is like as low as the piston will go. It will be at its bottom. The maximum radius or diameter that the conrod can move is limited to, when it gets all the way to the top, is like where the piston is. Right? So how do I do that graphically? Or how do I calculate that using here? Is I got my sketch. As always, I'm going to project the parts I want. The parts I want is the base over here, and I want this this whole curvature over here. So I know I need a circle that this particular radius of this circle, we can inspect that and say that this one is a radius of 15. And so I need this top of the circle to be it can't go above this part over here. So I'm going to draw a line from here and draw a line that goes down 15. Right, so this dot over here. And I'm going to use this as the path that my crankshaft to follow. This will be the very top of where that dot is, and the bottom will be where this particular dot over here is. I'm then going to use the circle tool. I'll use the 2-point circle tool. I'll press this circle over here and this one over here. So that's the circle that's the path that like the bottom of the bottom of the connecting rod is going to follow. And I can also use the center of this circle so therefore that is the radius that the crankshaft is going to rotate around. So I will use this sketch later for that. But for now, let's just make this particular circle in here of this size. Finish sketch. We'll make this, make it that big. Let's say we want it to be slightly larger. Again, you can be more accurate with your things because you have more than one class to do it. We got that part there, and then we can do the crankshaft. So this, I made a mistake. I made it a joint. So I'm going to go edit there, and I want it to be new body. And this is going to be part of the crankshaft. Then Fusion, as always, hides your sketches once you've used it. So I'm going to unhide our first sketch that has that circle we wanted. I'm going to create a sketch. Sorry, not create a sketch. I'm going to edit this sketch that we had visible before. Edit sketch. I'm going to make another component. I'm going to make the center part of this crankshaft. Let's say I want that to be sketch dimension 20. Finish sketch. Extrude. So when we extrude it, we want to extrude in this direction, and so this one we want to offset this because by default it's going to start here and it wants to touch this piston, but that's not really where we want the conrod, the crankshaft to be. Otherwise it's going to be getting too close to our piston. So we're going to actually use, when we start, instead of starting from the sketch, we're going to offset it, which means we can do a tool over here, and if we press like minus 5, so it actually starts offsetting that particular part. Actually, for this one, I'm going to go minus 15 because we'll join it later. And this is going to be the crankshaft. Okay. And that should have made a new body. Now we're going to join these two together. I'm going to hide the piston. I'm going to hide the piston, hide the wrist pin, hide the conrod, And now we can actually hide this sketch. We don't need this sketch anymore. But we want to link these two together. So we'll do that. We'll sketch over here. We will project this, the bottom, the lower part over here. Okay. We will use the tool we had before. We do this and this. And then if we do a line, how do we do that? We do this like that. And then if I go and I'll do another line over here. And then I will press escape and I will press this and this. And I should go over here, make it a tangent and do the same thing, this. And I'm holding shift so I can select multiple parts here. Oh, it's already a tangent. Press this line and tangent, okay, and this one and this one. There we go. So they're all tangented. And now I should be able to cut. Can I cut that? No. So all I've done here is I want a line on the outside, so I can press this offset. So I can press this line, and let's say I want it to be slightly larger. So -5 will mean I'm going to have a 5 millimeters of material around it. This is the size that I want that shaft to be, the connecting part. And then I will just extrude these together, and it should, because I hid everything else here. The reason why I hid everything is I actually want to make these two parts join together. If you have everything hidden, it's not going to consider it in the join, but I do want these two connected together. So I should go like that. And we should have body 5 and crankshaft should connect together. Wonderful. So now that's all the components we need to actually start doing our piston. And we've obviously done half versions of all these components. So you can really want to make them into the full size. You can use the mirror tool. So for example, this particular, let's do the connecting rod. So when you, I would like to save the design at this particular point. So let me save this. This can be the 2026 piston and liner class v1.0. So I'd like to save it and before I start doing all my doubling because I might want to change things later. But so how I would do this to make this connecting rod into the full size one that I can later modify is I'm going to use like the mirror tool. So I want to mirror this particular body. The mirror plane, I want to mirror it like that. Press OK. So then now we've got that thickness over there. And then before I finish the mirror, what I'm going to do is I'm going to drill the holes in here so that I don't have to drill the hole twice. So let's say this particular one needs a 5 millimeter hole because that's the size of the nut we have. Press OK. Extrude. We'll extrude this in both directions. We want it both up. Up and down. Okay. And then we also, the nuts have, the bolts have a bit of a thickness themselves. So we need to also cut a bit more into here. Let's say we want it to be 10 mil. We need to cut a bit more to fit to do that. And then we might also want to do things like round off. How did I round it off? I made it look very good in my last one. I think I went here and I did a 3 tangent circle for this line, and this line. And so I have that lovely looking circle like that. And then before I finish that, I needed to so I want to cut off this particular shape here and including this part over there to make it look good. symmetry just to cut off the top and bottom, and we go like this. That's going to make that part of the piston look nice. And then let's say I like this, all looks good. I can then mirror this whole shape using this particular mirror plane over here. And what we'll use is we'll use this particular part in like one of the stress analyses. This will probably be a good one to show it because we can see there might be some small cracks generating in particular areas of this part. And then I would save this one as, it's probably a bit too thick there, but we can adjust our components. Oh, actually, I'll show you how to do that. But first, I'm going to save this one as file, save as, and we're going to save this one as version 1.1. So I know this version 1.1, 1.2. So let's say we did our thickness there and we said, oh, actually, that's very, very close to the crankshaft there. So now we can start doing some adjustments that we can do in CAD. We can go to modify and we can move or copy. We want to move this particular crankshaft and we can just move it to probably minus 0.5 is the way to go. And so there, that matches. And now I know this doesn't realistically make sense. That's very thin and that's very thick, but oh well, it's just how it turned out. So next lesson, I'll show you how we can, I'll do a stress analysis. Maybe between now and next lesson, I can show you the replay of it. But I'll show you how we can then animate it and then why we bother animating the particular sketch. And so that we can get some nice looking well, not graphics, but we can, more than making it look pretty, we can find some actual information on this particular part.